In this video, we are going to go over topic 4.3, which is solving a system of equations by the elimination method. So our content objective, our students will demonstrate solving a system of equations by the elimination method using the guided notes in Desmos. The students will determine if their answer is one solution, no solution, and infinitely many solutions. The language objective is students will write the steps of the elimination method to find their answers of one solution, no solution, or infinitely many. And then the learning target will be I can solve a system of equations by elimination method. So for bell work, chose to start off thinking about opposites because we're going to be dealing with opposites a lot. So opposite integers, -4 and 4, they have different signs. And then also opposite terms. So think of positive 5.6y and negative 5.6y. And then 2x and negative 2x. For bell work question number 2, wondering if these are the same graphs. So which of the equations above will produce the same graph as x plus 2y equals 4? And check your guess by graphing the equation on the next slide. So we have 3x plus 6y equals 12. Notice that when we type it, it overlaps that dotted line that was there. So right away we know that it is the same. Let's see if that's true for the second one. The second one was 7x plus 14y equals 28. So 7x plus 14y equals 28. That is also the case. Now let's go back and see if I change that to a 20, which is probably what you'll actually see on your bell work tomorrow. If you see a 20, let's see. And I change that. So 7x plus 14y equals 20. We can notice that these are not the same lines. They're actually different. So since they're different, that's a concern. So that means that they're not the same. They're not equivalent. They may have the same slope, but different y-intercept. So your goal is to choose at least one number to multiply by that you think that no one else will think of. So we know that the equation, the first equation will work. Now let's come up with our own equation. You can multiply the whole equation by, let's say, 6. That will work. You could multiply the whole equation by -3. -3 times x is -3x. -3 plus 2y is -6y. And then don't forget the -3 times 4 is -12. So that works too. So we are going to be multiplying equations to change the look of it, but not to change the actual value of the equation. We're still dealing with the same line, we're just changing how it looks to help us. So in our next slide, we'll explain a little bit. So just an important fact to remember. Remember that multiplying both sides of an equation by the same number creates a new equation with the same graph. So it looks different, but honestly it's the same. So I want you to keep that in mind because it's going to be super helpful later in this activity. Now for this flow map, it looks overwhelming, but remember it's just steps. So you can solve a system of equations by the elimination. As you get better with noticing opposites, you might find a quicker way of solving a system, but this flow map will work every time. when the same variables are on top of each other, when they're lined up. So the first step, you want to multiply the first equation by the opposite first coefficient of the second equation. And then multiply the second equation by the first coefficient of the first equation. So that part's a little hard. We'll explain it in the next slide. Then you're going to add the two equations together, and then you're going to get a one step. So once you solve that one step, then you are going to plug it back in and get the second variable. Now, if you add the equations and you're left with no x and no y, then you move to the right of the flow map. And then if you have a true statement, infinitely many. If you have a false statement, then the answer is no solution. So let's get to work. We have the system of equations. Notice that our x's are lined up and our y's are lined up. That's exactly what we're looking for. Now the flow map said multiply the first equation by the opposite. So opposite number, and then the second one said multiply the second equation by the same number. So let's be specific. We are talking about the leading coefficient. So we're talking about the numbers in front. So we are looking at the 4. We're going to make that opposite. And then we're looking at the 6. And we're going to keep it. So you only change one of them. And then we're going to write our equations. Now this is where your bell work is going to come in handy. We are going to change the look of these equations, but not their identity. Their graph will stay the same if we multiply correctly. So, negative 4 times 6x is negative 24x. Negative 4 times 2y is negative 8y. And then don't forget, remember my little remember, you have to multiply the other side too. Negative 4 times 12, or negative 12, is a positive 48. Now we get to do the second equation. With the second equation, we multiply the 6. 6 times 4x is 24x. 6 times 3y is a positive 18y. And then 6 times 7 gets you a positive 42. Now in the third step of that flow map says that we have to add these two equations together. So that's our goal here. So notice negative 24x plus 24x eliminates. That's why we call it the elimination method. Then we have negative 8y plus 18y, which is 10y. And then 48 plus 42 gets us 90. Now we have a one step. Divide by 10, and we're left with y equals 9. Now it becomes a substitution problem where we have to substitute 9 in to any one of those equations. I would choose either the first one or the second one. Does not matter. I'll choose the second one because it doesn't involve any negatives, but you'll get the same answer no matter what. So then we have 4x plus 27 equals 7, minus 27 on both sides. So then we have 4x equals negative 20, and divide by 4. X equals negative 5. So we have an ordered pair. We have one solution. We have negative 5, comma 9. Let's double check to make sure that is correct. We have negative 5, We have 9. All right, we're good to go. So this is an ordered pair. It is a 1 solution. So on the next slide is just me going over it in case you wanted to look at it. All right, let's get into this problem. Once again, you're multiplying the first equation by the opposite, and then you're doing the second with the same. So we're looking at these numbers. Be careful, there's a number in front of that x, it's a 1. So the opposite of -2 is a +2. We're going to keep that 1 the same. So now I'm going to multiply by 1. So we're just changing the look of the equation. We're not changing the line of the equation. So we have the original and then we're going to multiply. 2 times x gets you 2x. 2 times 2y gets you a positive 4y. 2 times 4 gets you 8. And then multiply by 1. When you multiply by 1, nothing changes. Negative 2x times 1 is negative 2x. 1 times negative 5y is negative 5y. And then 1 times negative 1 is 1. The third step of our flow map is adding the 2 equations together. So notice in this flow map, if you do it our way, the x's will cancel. So 2x plus negative 2x cancel, they eliminate. Then 4y plus negative 5y gets you negative 1y. And then 8 plus negative 1 is 7. Going to divide by negative 1. Now, you get to choose either equation number 1, equation number 2. This time I'll choose equation number 1 because, once again, there's no negatives. Sometimes you're not going to luck out, but this one seems to work. So x and then minus 14 equals 4. We get to add 14 on both sides. So then we have x equals 18. Now remember, our goal here is to put the answers together to make the actual answer, which is 1 solution. It's an ordered pair. So our ordered pair, our x is 18, our y is negative 7. And then I even have this bubble, even though I can't get to it. Right. I move my screen up. Sorry guys, I was blocking. If you click 1 solution, it's going to say excellent. All right, we did it right. So we're good to go. All right, the next slide is just honestly the same thing. And now you would try it on your own. So these are the triads. So one thing that you need to remember is make 1 opposite, make 1 the same. And you're looking at these beginning numbers. So I see a positive 3, I'm going to make an opposite, which is negative 3, and then I'm going to keep that 2 the same. So then I have the original equation, and then I have the original second equation. And you're just changing the look of that equation. You're not actually changing the line. Very important for you to distribute correctly. One small mistake is going to change the entire process. So please be careful. Okay, at this step, we have an adding problem. So negative 6x plus 6x goes away. Then we're left with negative 15y equals negative 60. Now remember, on each of these slides, got this calculator in case, the negatives worry you. You can double check. Just input exactly what you see. You can even do the coefficients. Negative 3 plus negative 12. That's how I got negative 15. If you're worried about division, so it gets you a positive 4. So that calculator is there for you at all times. So then I get y equals 4. Now, once again, pick the easier equation. Does not matter. You're going to get the same answer. So if I have 2x plus 4 equals 10, I'm going to minus 4 on both sides. Sorry, I ran out of room again. And I have 2x equals 6. Divide by 2. I have x equals 3. So my ordered pair would be 3, 4, which is going to be one solution. So we can confirm that. So let's double check. Our x is 3, y is 4. All right, cool. And then we have one solution because it's an ordered pair. All right, and the last try it. And this is the slide if you need to upload your work. All right, so we have our first equation and our second equation. So once again, opposite number, same number. So we're looking at these first coefficients. So the opposite of a positive 3 is a negative 3. And then the same would be negative 6. So keep one the same and one opposite. Then rewrite the equation. Make sure when you are rewriting the equation, your x's and y's look correct. Also be careful that you can read your own handwriting. Some students forget to transfer over one small piece and then their problem's wrong. Especially these negative signs right here. So make sure that you are writing the negative signs. All right, and let's distribute. Negative 3 times negative 6x is 18x. Negative 3 times negative 12y is a positive 36y. And especially use the calculator for these bigger numbers, numbers that you're not used to multiplying. So negative 54 would be on the right-hand side. So make sure you multiply all the way over. And then we can do the bottom one. So negative 18x. Negative 6 times y is negative 6y. And then there's that another number. And the other thing that's nice about this calculator is that it saves your information. So that will get you a positive 84. Okay, this is just one big adding problem. 18x plus 18. I'm sorry, this should be a negative 18 right there. This 6y should be a negative. This is where you got to be very careful. with your signs. Notice that I had 2 equal signs. That doesn't make any sense. You need to have 1 equal sign for each equation. And then you have the 84. So always double check. So then we have 36 plus negative 6. So that's going to get us a positive 30y. And when you're typing in the calculator, you want to do it exactly how you see it. So negative 54 plus 84 gets you a positive 30. And then divide by 30. And then y equals 1. So you get to choose which equation you want to use, either the first equation or the second equation. I'm going to use the second equation. So once again, you get to decide. So we have 3x plus 1, because that goes into our y, equals negative 14. Especially if you're writing on the screen, sometimes your pen doesn't work, or maybe you highlight over something. So just double check. And then we minus 1 on both sides. We have 3x equals negative 15. Divide by 3. We have equals negative 5. So we have an ordered pair. We have x, which is our negative 5. And then we have our y, which was 1. So make sure at the end you put it in an ordered pair. Since it's an ordered pair, it's one solution. And then we have negative 5. We have 1. Let's check. All right, we did it correctly.